Hi everyone, I'm going to lead us through solving equations. This is a skill that you've been doing for quite some time, actually. You probably actually learned it, or at least part of it in middle school, and you absolutely learned it in Algebra 1, geometry, and we did a bunch of it this semester in Algebra 2. But this is a good place for us to start with this remediation process, as you're going to have to solve equations in just about everything we do. So we're just going to do a quick refresher on that. I'm still going to lead you through a few types of problems, talk about a couple important things when we're doing so. That way we can master the skill, which is going to set us up to be a little more successful with some of the other topics you're going to work on in this remediation process. So let's get going. So anytime you're solving an equation, you're essentially trying to get all the variables on one side and numbers on another side. Now, variables are all the letters that show up in an equation. Before we get to moving things around, you always want to simplify each side. So what does that mean? So let's write this down. To simplify means to, one, distribute. And remember, we distribute anytime we see something in parentheses. And if we have something in front of those parentheses besides just a +1, we're going to distribute that into those parentheses. So we're going to distribute, and then we're going to also combine like terms on the same side of the equal sign. So we want each side of the equation to be simplified before we go ahead and start to solve it. This is really, really important and actually makes solving the equations much more straightforward. So let's get going with a few examples here. So I first noticed that the left side is simplified, right? It's just a number. There's nothing that I can combine it with. There's no distribution. So we're going to leave that -152 alone. On the right side here, though, I see this 8 in front of the parentheses, which can distribute. Now, drawing those arrows, you might think is very basic, and it is, but it tells our brain to multiply this 8 to both the 5 and the -3v. So that's where we're going to start. 8 times 5 is 40. 8 times -3v is -24v. So now we only have one term that has a variable. That's the v. Since we only have one term with a variable, we're going to leave that v on the right side, and we're going to work to get the numbers on the other side. So if I see a +40, I have to undo it if I'm moving it across an equal sign. So I'm going to -40. So I'm -40 from both sides. -152 minus 40 is -192, and that equals -24v. Now that we have the variables on one side and the numbers on the other, we just need to undo what's happening to the variable. So when you see -24v, that really means -24 times v. So we're trying to undo multiplying by -24, which we can do by dividing by -24. That leaves us with just one v on the right side. I do need a calculator to do -192 divided by -24, which is 8. So this means that v is 8. Now remember, a good way to check to make sure that you've done your work correctly is to take the answer you get and sub it back into the equation. Okay, so we can always check this. Now, I'm not going to make you do this every time, but when you're taking an assessment, or if you're doing something on like the SAT or ACT, this is going to be a good thing to work on if you have the time to do so. So when I'm checking it, I'm ultimately trying to see, do we get both sides to be equal? So if I have -152 on the left-hand side, I should get -152 on the right-hand side. If that doesn't work out, there's a chance that we made a mistake in our solving. So let's check this. This time, we want to think about order of operations. Okay, we're still going to simplify the right side, but I got to think about what is the first thing I should do in terms of order of operations. Well, think about PEMDAS, right? PEMDAS. Parentheses come first. Well, we have a big set of parentheses right here, so I want to simplify inside there. Once we're inside the parentheses, this whole thing starts over. So we check again. Do we have another set of parentheses? Well, kind of with that 8, but there's nothing to simplify there. So then I'm like, okay, do we have any exponents inside these parentheses? We do not. Multiplication. Do we see multiplication? Yes. If we have a number in front of parentheses, they're wanting to be multiplied. Now this 3 is really a -3. So I'm going to do -3 times 8, which is -24. So now that I've multiplied, I see inside my parentheses, I just have 5 minus 24. So let's see what 5 minus 24 comes out to be. That is -19. Now that we're done there, we've dealt with our parentheses and we start this all over again. Parentheses, do we have them? Yes, but it's simplified. Exponents, no. Multiplication, yes, right? 8 times negative 19. What is 8 times negative 19? Hopefully it is negative 152. And yes, it is. So by the fact that we're ending with negative 152 equaling negative 152, we have checked our work and confirmed that 8 is a solution to this equation. Again, I'm not going to make you check every time, but that is a really good habit, especially when you're taking assessments. All right, let's work through some others as they all work out a little bit differently here. We'll save just for the sake of time. I won't check anymore, but we'll go ahead and solve the rest here. So again, first thing to do is let's simplify each side. The right side is simplified, right? I have -1 and -7x. Those don't combine. There's no distribution, so that right side's good. The left-hand side, though, I see parentheses and I see a term in front of it. That's just a negative. So I'm going to distribute that negative, making this 2 minus x minus 3. And it equals -1 minus 7x. Now I got to look for like terms. Do we have any? Yes, right? 2 and -3. Those can combine together. 2 minus 3 is -1. So I have -1 minus x equals -1 minus 7x. Now we have numbers and variables on both sides. So it doesn't matter if we want to bring the variables to the left side or right side and numbers to the other side. Let's go ahead and bring the numbers to the left-hand side and the numbers to the right-hand side. Let's do it one step at a time. So I'll add 7x. When I do that, I need to add it just to the x's, not to the numbers. So -1, that's going to stay the same, and -x plus 7x is positive 6x, and it equals -1. Now I need to add 1 to get the numbers all on the right-hand side, and when I do so, that gives us 6x, and -1 plus 1 is 0. Well, this is an equation that a lot of students get stumped on once they get here, and they say, there's no solution. Well, think about what we did here. Once we got the variable by itself with the number in front of it, we divided by that number. We're still going to do that. And I can divide 0 by any number. But every single time we take 0 divided by some number, that's just 0. So the solution to this equation is 0. Okay, so don't let that 0 throw you off there. All right, let's chug along. Number 3, again, going to be a little bit different here. Left-hand side is simplified. Right-hand side, I notice parentheses. I'm going to distribute that -6 into the parentheses. So 31 minus 6n equals -6n plus 36. Just like before, let's try to get the variables all to the left-hand side. So I'm going to add 6n to both sides. And when I do that, all the n's go away, leaving us with 31 equals 36. Well, if the variables go away, this is the point where we might think about it being no solution or infinite solutions. It's no solution if this is a false statement, which this is, right? 31 does not equal 36. So this is no solution. Had we gotten something like 36 equals 36 or 0 equals 0, that is a true statement, which would lead us to conclude that it is infinite solutions or all solutions. All right, that concludes just kind of like the multi-step linear equations. Let's talk about solving some absolute value equations, which we did this semester. Idea is kind of the same, but now instead of trying to get just the variable part by itself, we first need to get the absolute value part by itself, which in this case is the absolute value of -10x. So we got to think about, what do we do with this 2? I always ask all our students, when you see this, to read it out loud. So what does this say? Absolute value of -10x divided by 2. Well, saying that divided by 2 gives us an idea of how to undo that, right? How do we undo dividing by 2? By simply multiplying by 2. So if I take 2 and divide it by 2, I'm going to multiply by 2, leaving us with just the absolute value of -10x equals 10. Once we get absolute value equal to some number, this is where we're going to get 2 different equations. Now let's talk about why. Remember what it means to take the absolute value of something, right? It means to measure its distance from 0. So it's always positive. So if I try to figure out the absolute value of what numbers equal 10, what are those numbers? Well, there are 2 of them. The absolute value of 10 equals 10, and the absolute value of -10 equals 10. So what we need to have happen is we need what's inside these absolute value brackets to equal 10 and -10. So how do we do that? We do that by first dropping the absolute value brackets and not changing a single thing. So setting what's inside there equal to +10, and then we'll set it equal to negative 10. Because we want that term to equal positive 10, and then we also want this term to equal negative 10. And now we have two equations to solve, just like what we did up here. So I'm going to divide by negative 10. I get x equals negative 1. Again, divide by negative 10 and get the x equals positive 1, giving us two different solutions, 1 and negative 1. Right, just a little more complex absolute value equation. The idea is still the same. Our goal is to initially get this absolute value term all by itself. So what are the first steps in doing so? Well, we need to undo this 5 and this 3. Well, this 5 is really going to be the first thing that we want to deal with. If we try to divide by 3, we have to divide every single thing by 3, and that's going to create some fractions, making it much more complicated. So let's go ahead and subtract 5 to start. I'm going to subtract 5 on both sides of the equation, leaving me with 3, absolute value of negative 8x, plus 10 equals, what would that be, 66. Now, this 3, it wants to distribute inside the absolute value brackets, just like parentheses. But we can't do that. If we do that, we might get one solution right, but it's not going to help us find the second solution that we need with these absolute value equations. So if we know it wants to distribute, the operation when we distribute is to multiply. So how do we undo it wanting to multiply? By dividing. So I'm going to do that undoes the multiplying by 3. I got to divide 66 by 3, which gives us 22. And now we have the absolute value term equal to just a number. The idea is just the same as what we dealt with up here. What do we want the inside of the absolute value brackets to equal? Well, what numbers, when we take the absolute value of them, give us a positive 22? That'd be positive 22 and negative 22. So we need what's inside these absolute value brackets to equal 22 and negative 22. So we're going to create two new equations. Negative 8x plus 10 equals 22, and negative 8x plus 10 equals negative 22. And we're going to solve them just like we did before. So minus 10, giving us negative 8x equals 22 minus 10 is 12. And then divide by negative 8. This is going to give us a fraction. That is okay. We'll just leave it as a fraction. We'll call one of our solutions 12 over negative 8, or divided by negative 8. And then the other one, steps are going to be the exact same. Subtract 10. So negative 8x equals negative 32. Divide by negative 8. And x equals 4 as our second solution. All right, well, that concludes your first remediation note video. You should now work on completing the remediation practice, which is in your remediation packet. Thanks for watching and have a great rest of your day.